The Klein model is the latest one in the FLUX.2 series. It can generate realistic style characters and images with diverse styles. It can precisely edit specified content in the image. Changing clothing colors is a breeze. Swapping subjects is no problem. It even knows how to pour cola for guests. Transform image styles, turn into figurines, enhance image details, change image perspectives, and restore old photos with one click. It supports multiple reference images, enabling outfit changes, face swaps, and composite image generation. Klein is a unified model. Just load a single model file to simultaneously perform high-quality text-to-image, single-image editing, and multi-reference generation and editing. It is also a lightweight model. Using the 9B Distilled model with the most parameters in the series, which produces the best results, it only takes 4 steps and a few seconds to generate an image, incredibly fast. Of course, no model can be perfect, and Klein has some issues too. For example, portraits tend toward Western style with a bit of an AI look. Anatomy isn't that great, limbs and especially fingers are prone to errors. Text rendering is poor, and understanding of complex compositions and spatial relationships is weak. However, in my opinion, given the advantage of lightning-fast generation, these aren't major issues. After all, in the time a competitor generates one image, Klein might have already rolled a dozen times. In today's video, let's chat about this highly cost-effective, little powerhouse model. The FLUX.2 Klein model was released by Black Forest Labs in January 2026. The official release includes models in 2 parameter sizes, 9B and 4B. The full model is in BF16 format, and the 9B model also has FP8 and NVFP4 formats available. Each parameter version is further divided into base and distilled versions, so there are indeed many model files. But don't panic. After extensive testing, I can confidently say the 9B model performs far better than the 4B. The base version is more suitable for fine-tuning with slightly better output diversity, but falls short of the distilled version in both quality and speed, so I only recommend using the 9B distilled model. The full BF16 format 9B distilled model is 18.2 GB. You'll want at least 12 GB of VRAM to run it smoothly. The FP8 version is more accessible at 9.43 GB, supporting entry-level graphics cards with 6 GB VRAM. NVFP4 is an exclusive optimized format for NVIDIA Blackwell architecture, only 5.76 GB. If you have a 50 series NVIDIA card, this is very suitable. Otherwise, I recommend the FP8 format for the best balance of speed, VRAM requirements, and compatibility. Additionally, Unsluth has converted and released GGUF format models, making it easier to choose different quantization levels. Q4KM, Q6K, and Q80 offer good value. The text encoder uses QN3, the 9B model pairs with QN3-8B, and the 4B model pairs with QN3-4B. Both have FP8 format options. The VAE is FLUX.2 VAE. To use the Klein model, you need to upgrade the Comfy UI core version to v0.9.2. I'm currently using my unreleased portable package V8 with core version v0.1, and it works perfectly. There are 5 Klein-related workflows in the template library. The birthday hedgehog in the bottom left corner is a text-to-image workflow. Let's load it up. Honestly, I don't really like this kind of workflow that hides detailed information in subgraphs. It might look clean, but it's very inconvenient for adjustments. Let's expand the subgraph nodes to expose all the nodes inside, then make some tweaks, and we end up with this workflow. The entire workflow can be divided into 4 parts: model loading, prompt and size settings, sampling and scheduling, and image decoding and saving. Let's first select the locally downloaded version of the model. As I mentioned when introducing the model, I most recommend the 9B Distilled model. It performs better across all areas including text-to-image, image editing, and multi-reference generation. Let's select its FP8 version here. Let's also select Clip and VAE. Note that the 9B model uses QN3-8B as the text encoder, with type set to FLUX.2. Keep the prompt and parameters unchanged for now. I'll explain them in detail shortly. Click Run. The image comes out quickly, but since this is a new portable package, it's missing a timing plugin. Let me install it. Done quickly. After restarting, run it again. You can see that sampling a 720 by 1280 large image only took 13 seconds. This recording was done on my local 4880 graphics card. Without recording, it usually only takes 5 seconds. That's incredibly fast. Let's look at the output quality. Quite excellent. Realistic characters, rich details like hair strands and clothing textures. Background blur is just right. Overall color tone is unified, with soft and natural lighting. Since this is portrait generation, let's compare it with Z-Image Turbo. In my opinion, Klein's strengths are atmosphere, composition, and artistic expression, while Z-Image Turbo excels at portrait details, skin texture, and refinement. So if the goal is portrait generation, I would lean toward using Z-Image Turbo. But when it comes to other styles like fantasy, illustration, concept design, or scenes requiring strong artistic expression, Klein has the advantage. Now let's look at the parameters. For image generation, the most core part is the prompt. The official team provided a very detailed prompt guide, summarizing the core philosophy. Use natural language to describe the image clearly. Ideally, follow the order of subject, scene, details, lighting, then atmosphere or style. Lighting is crucial. Describing the light source, texture, direction, color temperature, and interaction with objects in detail helps a lot. You can add style, mood, and technical details like focal length and depth of field at the end. Avoid negative instructions. Don't write negations like, don't show blah blah blah. Our earlier prompt perfectly follows these requirements. If you find writing prompts manually too tiring, you can use this system instruction and delegate to any large language model. Doubao, Qwen, or Yuanbao all work great. Let me try with Qwen. Paste the instruction, enter a squirrel eating nuts, and quickly get this prompt. Copy it into the Comfy UI workflow as the positive prompt. Click Run. And here comes a chubby squirrel eating nuts in a forest. The style is cozy and whimsical, so it's not going for photorealism. The lighting, atmosphere, and details mostly match the prompt requirements. The only issue is the squirrel's tail is upright and fluffy, not curled around its body. This is one of Klein's flaws. It often ignores some parts of complex prompts. Like other models, I've added a FLUX Klein text-to-image prompt generation node to the Me Nodes plugin. Add it to your workflow and use any large language model platform's API. I'm using SiliconFlow's free GLM4 model here. Enter a simple prompt in Chinese or English, click Run, and watch it expand into a long, detailed prompt. The final output is indeed excellent. The Klein model can understand Chinese prompts. Let's remove the prompt generation node and enter the Chinese version of our first demo prompt. Click Run. Like Hunyuan Video 1.5 and similar models, when using Chinese prompts, the overall image quality is similar, but facial features tend to be more Asian. However, after running many tests, I found that once prompts get complex, Klein's understanding of Chinese becomes problematic, either missing details or misinterpreting. So for more stable results, I still recommend using English prompts. The Klein model inherits FLUX.2's flexibility, supporting various sizes and aspect ratios. The optimal range is around 1 megapixel, such as 24 by 24, 720 by 1280, etc. For pure text-to-image rather than image editing, anything under 2 megapixels is stable. I kept the 9:16 ratio and generated these images from small to large. They all look great. Since we're using a distilled model, steps can be very low. The official recommendation is 4 steps, but I prefer running 6 steps. It takes a bit more time but yields richer details. Anything from 3 to 9 steps works. Keep CFY at 1. We can choose from many sampler and scheduler combinations, but there's no noticeable quality difference. The template workflow uses a FLUX.2 specific scheduler. I compared quite a few and found no particular advantage, so I recommend sticking with the default ELR plus simple. Models are getting stronger while parameters are becoming simpler and more worry-free. Although Klein doesn't have as many low arrays as Z-Image or Qwen Image, there are still some practical ones. For example, I personally love the dark Ghibli-style low array. Download it to the model's low-res directory, then add a node to load the low-array model into the workflow. Add the model's trigger word at the beginning of the positive prompt, and remove the photorealism emphasis at the end. Click Run. The low array effect is obvious. The image is delicate and full of mystery. When introducing the model, I mentioned that the 9B Distilled model is my top recommendation. Other models have their issues to varying degrees. Now let's take a look together. Remove the low-raw loading node and the trigger word from the positive prompt. Select the 4B Distilled model. The text encoder needs to be changed to QN3 4B. Keep other parameters unchanged and click Run. Oh my, the character has extra hands! Let me change the random seed and generate 4 images. Except for one that cleverly hid the hands, the other 3 all have issues to varying degrees. So avoid the 4B model if you can. For those with limited VRAM, you can absolutely use the GGUF version of the 9B Distilled model. Add a GGUF model loading node, select the Q8A0 quantized version, and remember to change the text encoder back to QN3 8B. All other parameters remain the same. Run it to get this image. Even using the smaller Q4A0 model, the results are much better than the 4B model. Would the 9B non-distilled model be better than the distilled version? Actually, no. Let's load the 9B base model, increase steps to 20, set CFG to 5.0, and click Run. With more steps, sampling time increased to half a minute. The final result looks like this. Compared to the distilled model, it falls short in details, colors, and overall quality. This is actually normal. The base model is more of a foundation for fine-tuning, while distilled models typically undergo targeted optimization, quality enhancement training, and post-processing improvements, making them better out of the box. To summarize, just download the 9B Distilled model. If you have limited VRAM, you can confidently use the GGUF quantized version with minimal quality loss. More than text-to-image, Klein's real strength lies in image editing. The reason is simple. There are already many fast, high-quality options for text-to-image with fierce competition, but for editing models, the only alternative is the heavy QN Image Edit 2511. Load the Klein image editing workflow. Compared to text-to-image, it just replaces the size settings with image input and processing. Let's start with model loading. Since Klein is a unified model, the model file is the same as for text-to-image. I still recommend the FP8 version of the 9B Distilled model. Upload a portrait of a girl in a JK uniform. Note the node after this. It automatically scales the image to around 1 megapixel while keeping both dimensions as multiples of 64. As mentioned for text-to-image, this is Klein's comfort zone. Without this node, if you upload a particularly large image, the VAE encoding node might freeze your entire computer. Of course, if your image is already small or you're confident in your hardware, you can disable it. Image editing prompts have fewer requirements than text-to-image. The core principle is, describe the change, not the content. Since the reference image already tells the model what it is, the prompt just needs to specify what to change. My prompt follows this principle. Change her shirt from white to pink. Keep the negative prompt empty. In the sampling section, you can see that image editing uses a blank latent image of the same size as the original after resizing as a base for fresh generation, not im repainting. Other parameters are the same as text-to-image, so we won't dwell on them. Click Run. Image editing sampling takes a bit longer. 6 steps took 22 seconds. The final result is perfect. The shirt changed from white to soft pink with realistic shading transitions, preserving the original lighting while everything else remained unchanged. I connected an image comparison node to verify. Yes, the modification range is very precise. If the prompt was to change the sweater color, or the entire top including both sweater and shirt, it would also work perfectly. It hits exactly where you aim. Let's try a different prompt to recreate the viral real person to figurine effect from Nano Banana. The result is fantastic. All character and clothing details are preserved, and the figurine specifications, style, scene, and photography parameters all strictly follow the prompt requirements. Changing perspective is also simple. For example, I wrote in the prompt, switch to a top-down angle. Klein accomplished the task perfectly, transforming from the original eye-level view to a bird's-eye view while preserving all character elements and reconstructing an appropriate scene and lighting. Some might say, the effect is great, but I can't write prompts for different angles. No problem. You can search and install a plugin called QN Multi-Angle in Manager. Its dependencies are simple. Just restart and refresh the page after installation. Add the multi-angle camera node provided by this plugin, input your image, connect the output prompt to the positive prompt input, and you can visually adjust the shooting angle. I randomly adjusted it and clicked Run. The resulting image's camera angle changed slightly, but not much. Looking at the generated prompt, it says front right, too similar to the original, so I adjusted directly to eye-level close-up front view and ran it again. This time the change is obvious. Character consistency is great, scene reconstruction is reasonable, and lighting is handled excellently. Remove the plugin node. Now let's look at another common editing scenario: converting animated or anime-style characters to realistic photos. Upload a 3D animated illustration. The prompt simply asks to convert this image to realistic photography. Looking at the result, while preserving the original composition and elements, it successfully transformed the character, scene, and flowers into a photorealistic style. Klein also excels at restoring old photos. Upload a low-resolution old photo, only 177 by 285 pixels. There are many ways to write the prompt. My favorite is this one, asking to convert the image to high-quality colored DSLR photography style. The output resolution increased to 832 by 1280. While remaining faithful to the original, it added sharp, clear details. Natural light streams from the front left with soft shadow transitions, presenting a professional DSLR photography aesthetic. When using Z-Image Turbo for portraits, we often encounter insufficient detail. Typically, Seed VR2 is used for enhancement, but now Klein can also achieve good results. Upload a 720 by 1280 portrait. Since I only want to add details without changing the size, I disabled the resize adjustment node. Click Run and quickly get this optimized image with significantly improved details. The lighting on the face, as well as textures on the fuzzy jacket, pleated skirt, knee-high socks, and boots are all notably enhanced. However, since Klein repaints the entire image, sometimes the detail changes might be too significant. If you want a more stable approach, you can VAE encode the original image and pass it to the sampler with a lower denoising strength, like 0.5, preserving more of the original content. If Seed VR2 did the same task, the result would look like this. In comparison, Klein's output is more like realistic photography with soft, natural lighting. Seed VR2 produces a high-contrast digital HD style with stronger sharpening, prioritizing extreme clarity. Klein supports multi-reference compositing. You can edit based on one image while using another as reference, or combine elements from multiple images into a new one. Let's try the first approach. Copy the image upload and reference-based prompt update nodes, and connect the wires. Image 1 is an idol singer. Image 2 is a cute knitted-style cat sitting on a volcano. We want to edit Image 1 using Image 2's material as reference, so disable Image 1's resize adjustment node and define the blank latent image size using Image 1's dimensions. Image 2's can be enabled, though note that it won't change upon 24 by 24 input. Write the prompt like this, clearly requesting to change the skirt material in Image 1 to the knitted style from Image 2 while preserving the original composition and lighting. Click Run. Oops, everything else is perfect, but the tulle underskirt layer didn't change. Let me change the random seed and run 4 images. Looking at the results, except for the second one having an extra cat, the other 3 are all perfect. Material conversion is thorough, with knitted texture throughout the entire skirt. Composition and pose are perfectly preserved, recreating the puffiness of the sleeves and skirt hem. Restore the previous seed and image count settings. Swap Image 1 to a sailor-suited girl by the sea, and Image 2 to an outfit set including a plaid top, denim mini skirt, off-white bag, lace leg warmers, and platform shoes. The prompt is simple. Have the character in Image 1 wear the entire outfit from Image 2, keeping everything else unchanged. The result looks like this. I'd give it 80 points. Original elements are perfectly preserved and most clothing elements transferred successfully. The flaws are: the top changed from a halter neck to a regular tank top, and the shoes are similar but not identical. Now let's swap both Image 1 and Image 2 to portraits and try face swapping. The prompt simply requests a face swap. The result is out. The swap was successful. However, image 1 has a soft Japanese photography style, while image 2 is fashion photography. Their tones and lighting are completely different. The model strictly preserved the original facial features, creating some disconnect between the two images. But we can use Klein to unify the style. These two prompts achieve different processing approaches. Both work well. Though called a face swap, the headscarf got swapped too. We can use a more precise prompt to avoid this, or use inpainting to ensure only the face is modified. Open the mask editor on image 1, paint the face area, then use the inpainting node to apply the mask range to the prompt and pass it to the sampling node. For better results, you can blur the mask edges. The prompt and other parameters don't need changes, just run it. See? The headscarf didn't come along. Then use the same method for post-processing to ensure the face coordinates with the rest. But personally, I still prefer Reactor for face swaps. It's fast, simple to operate, and has unified tones. What do you think? Every time an editing model is released, people ask if it can be applied to e-commerce product images. Let's try. Restore the workflow to basic multi-image editing. Swap image 1 to a perfume image and image 2 to a marble background. Write a detailed prompt, emphasizing contact to prevent the object from floating, asking the model to adapt to the new environment according to perspective alignment and proportions, and generate correct shadows. The final result lived up to our expectations. Lighting integration is perfect, and the perfume bottle's base creates a reflection on the marble, greatly enhancing realism. But there are flaws. For example, some text details on the perfume bottle are lost. This is why I don't particularly like using editing models directly for e-commerce product images. However, we can first manually composite the product onto the background. This ensures precise details and correct proportions. Then let the editing model fix edges and relight for coherence. I won't expand on the specific operations here. Previously, we only gave the model 2 reference images. What's the maximum? There's no official statement, but in practice, I found it's best not to exceed 4. Now let's copy the image-related nodes and feed the model 4 images at once. Write the prompt like this. Have the character in image 1 hold the doll from image 3 and sit on the sofa from image 4, together with the character from image 2. I accidentally wrote image 3 for the sofa during the demo, but the smart model still found it. Since we're compositing on a completely new image, we need to sample using a blank latent image. Click Run. The model successfully integrated elements from all 4 images into one, maintaining visual consistency and naturalness. The interaction between the two characters is vivid. I won't demonstrate more operations. To summarize, in my view, Klein is an extremely cost-effective model. Using the 9B Distilled version handles the vast majority of text-to-image or editing needs. Even if you don't really need its text-to-image capabilities, a lightweight image editing model is essential. After all, while Klein Image Edit 25511 is more powerful, it has high VRAM requirements and slow generation speed. Alright, that's it for today's video. If you found this content helpful, please give it a like to support. All models, plugins, large language model system instructions, and complete workflows mentioned in the video are in the description. Feel free to grab what you need. See you in the next video.